Hi friends, myself Chandra Kumar. I am taking electrical machine design for the electrical engineering students of 7th semester. As per the previous lectures, now we will continue about the thermal process, and under this we are little bit discussion about the convection in the previous lectures. Now we will continue about the convection process. Convection is heat transfer by mass motion of a fluid such as air or water when the heated fluid is caused to move away from the source of heat, carrying energy with it. So that will be the process of the convection which will be associated with the heat transfer. Convection above a hot surface occurs because hot air expands, becomes less dense and rises. Hot water is likewise less dense than cold water and rises, causing convection currents which transport energy. As per the diagram, you may find out that at the place of the heater, we have the cold wire and the warm air will be moving away from that and the cold air will be moving towards this side. So there will be a cycle which will continue with the continue of the air moving the high from the lighter side towards the higher side, and it will be continuing in a process. Similarly, whenever we have to just cool all the water, we just hold the water in a bucket, we can find out there is a convection current will be flowing and the water is warmer, water is rises upward direction and the cooler water is moving towards the downward direction. So that will be the process will be continue until the whole water will be cooled down or the whole surface is whole surface is warm convection cells. So if we are looking over the diagram, we are finding that there is a small lines are there which will be reflected over within the green part that it will follow a particular pattern and it will and the direction of the air which will be moving from the lower side, it will be moving from lower to the upper one side. So convection cells are visible in the heated cooking oil in the pot at left. Heating the oil produces changes in the index of refraction of the oil, making the cell boundaries visible. Circulation patterns form, and presumably the wall-like structures visible are the boundaries between the circulation patterns. Heat dissipation by convection is classified into two categories. First is the natural convection, second one is the artificial convection. Natural convection will include however liquid and gas particles near heated body become lighter and rise, giving place to the cooler particles which in turn get heated and rise. This natural process due to changes in fluid density is known as natural convection. The heat dissipated per unit surface by natural convection is given by Q convection equal to Kc times theta 1 minus theta naught raised to power n W by meter square, where Kc is a constant depending upon the shape and dimension of hot body and a constant depending upon shape and dimension of hot body. Its value lies between 1 and 1.25. Theta 1 is the temperature of emitting surface, theta naught is the temperature of the ambient medium, and both of them in the degree Celsius. Taking n equal to 1, then the heat dissipated per unit area by convection, Q convection equal to Kc times theta 1 minus theta naught power 1. So lambda convection into theta, where lambda convection is the specific heat dissipation or emissivity due to convection measured in watt per meter square degree Celsius. Total heat dissipated by convection is Q convection equal to Q convection into S equal to lambda convection into theta into S in watts. Convection is a complicated phenomenon and heated convected depends upon multiple parameters like power density, temperature difference between the heated surface and the coolant surface, height, orientation, configuration, and condition of the heated surface. Next will be the thermal resistivity, density, specific heat, viscosity, and coefficient of volumetric expansion of fluid. And the last parameter is the gravitational constant. It also affected the on the conduction of the system. For vertical planes of height not less than 1 meter and with a temperature difference theta between the surface and the ambient air of pressure P atmosphere, Q convection equal to P 2 times of P is to zero point 0.5 and theta is per 1.25. For vertical tubes of diameter D meter, Q convection equal to 1.3 times D is to minus 0.25 and theta 1.25 watt per meter square. Next will be the artificial convection. In modern machines, heat is removed by artificial circulation of cooling medium. For example, a transformer tank can be cooled by blasting air on it, or a turbo alternator may be cooled by circulating hydrogen. This process is known as cooling by artificial convection. The usual method employed for cooling of machine is by blasting air on heating surfaces. These surfaces may be open or closed in this. The increase in heat dissipation by air blast is due to increase in convection. The problem of calculation of heat dissipation by air blast is very complex as it mainly depends on the construction features of the machine. These constructional details are different for every machine and so on. No effect, no exact relationship can be given for artificial convection. However, one of the most widely used formula for air blast on open surface is lambda dash convection equal to lambda convection into 1 plus kV root times V, where lambda dash convection is the specific heat dissipation of a blasted surface. Lambda convection is the specific heat dissipation by natural convection. V is relative velocity of cooled surface and air blast in meter per second. Kv a constant depending upon whether the blast is uniform or non-uniform in nature. Normally 1.3 for uniform blast and even zero point 0.5 for non-uniform blast. This will be the process of the convection which we are studying in detail under this lecture. So thank you for attending the lecture, and I think that you will be clear about the concept of the convection process and what are the different equations which will be associated with this one. And thank you.